Class, today the function that we are going to study is from operations on stack, and the function, as you can see on the board, is push function. So I've already written down the code. Okay, so we are going to understand how this code is executed, what is the concept behind it, so that it becomes easier for you to implement it programmatically. Also, we need to understand how the execution works, okay, for us to write this particular part of the code. So let's try to understand. The very first concept that we need to be very clear about is push, where push means inserting an element. Where are we inserting this element? Into our stack. So our stack, suppose, is of maximum size 4, right? And this is how my stack would be represented. 1, 2, 3, 4, right? I would be addressing it using just like an array, 0, 1, 2, 3. So that is max minus 1, as it starts with 0. Okay, I will have a pointer that will always point to the element that is inserted into my stack. So whenever I'm going to insert an element, my top will be pointing to that element. And also we know that stack follows LIFO, that is last in first out. So the top will always point to the last element that was inserted. So here, when I'm trying to insert an element, push is the function that I'm going to use. Now in this function, let's try to understand line by line how this code is executed. The very first line that you see is int x. So as we already know, we are going to insert an element. For that we need to accept an element. For that I have declared a variable x. And this variable is going to store the value of that particular integer, okay, which I want to insert in my stack. Now the second line of code that you can see is an if statement, which is talking about the condition is full. This particular condition is talking about is full condition. Now what is this is full condition? In this particular concept, we need to check whether our stack is full, right? For me to enter an element, I need to check whether there is space available for me to insert the element. So this is the condition that is checking. Now how am I supposed to know that, is my stack full? Now here we already know that our top is something which always points to the topmost element in my stack. Now if this top reaches to the maximum element number, so what is my max? It says my max is 4. So when I say max minus 1, that is 4 minus 1, 3. As you can see, the highest element or the last element that is going to be is 3, right? At the position 3. So if my top is pointing to this particular location, that means my stack has reached its limit and I will not be able to insert any element. That is what I'm trying to do over here. I'm checking this condition, and if this condition is true, I print that the stack is full and I return from this particular function. Clear? Now the second statement over here is else. What happens in else statement? Now suppose we have checked this condition and we still have space in our stack. There's still space in our stack. So I can insert the element. This condition is turned to be false. I come over here. Now what I do, my first line says x is equal to 10. Now this x is equal to 10 does what? Storing that particular element that I want to insert into a variable. Clear? Or you can accept it from the user as well using printf and scanf statements. So here I'll try to take that integer value and store it in a variable which I had declared at the start. Next what I do is, now here this line, very important. Whenever I want to insert an element, my top should be pointing to the location where I want to insert the element. Top always points to last element inserted, right? Top always points to last element inserted. So now if I want to insert a new element, I need to increment this top, that is top plus plus. Clear? So this line says what? Top is equal to top plus 1. That is, I need to increment my top. Now in this particular stack, suppose there is no element as of now. There is no element, the stack is empty. Where should my top be pointing? It should be pointing to minus 1. Right? Because the first element is addressed as 0, 1, 2 and so on. So my first element when I'm supposed to insert, I need to increment my top. That is top plus plus. Now the value of top would be 0, which was minus 1, it would be 0. Now 0th position, yes, I can insert the element. Now suppose the element is 10. I'm going to insert the element. How am I supposed to insert the element? Name of my stack. So the name of my stack is suppose stack itself. That is the variable that I have taken. Can you see that? Stack. And my top is pointing to the current position now where I have incremented it. So top is here now. So stack of top is equal to x. That is this line. Okay, so when I'm pointing over here, I'm inserting my element there. Clear? So your push function basically does check the condition is full. We need to try to find out first that whether there is space in my stack or not. Right? You have to accept a value for you to insert. Okay, many students would just miss accepting the value and write these two statements in a hurry. So don't do that. Accept the value from the user and then try to insert it. And there you have to see that you increment the top first and then you try to insert the value. Okay.